Hi everyone, my name is Bijisa Pyakurel, and today I will be presenting my poster on cog cues, shifting perception through interactive projected cues in still life drawing. In drawing training, instructors emphasize looking at the object of interest with the innocent eye to see it in its unfamiliar and unbiased form. Psychologists have linked this way of seeing the raw visual stimulus to an enhanced proximal mode or P mode of visual perception. Psychology literature suggests that skilled artists tend to strategically leverage and suppress their subjective view, or the distal mode of visual perception, to create faithful depictions. Drawing errors are linked to misperceptions that result from difficulty in switching between these two modes. Drawing techniques to recover the innocence of the eye and modern drawing training tools have focused primarily on motor skill. We differentiate our work in that we target the visual perception problem that precedes any motor input. We built a spatial augmented reality system and developed 3 interactive projected cues motivated by psychology literature and drawing techniques to enhance and suppress P mode and D mode of perception. Our work takes the first step towards understanding how such a system can be used as a cognitive training tool in drawing. Our first cue, the grid cog cue, is inspired by the grid drawing technique to help the user with positioning and avoiding D-mode constancy biases associated with the bilaterally symmetrical human form. The invert cog cue uses the figure ground principle of Gestalt psychology and the opponent processes theory of color perception to amplify the contrast between the figure and the ground. This guides visual selection to global aspects of the image. The spotlight cog cue facilitates P-mode perception by directing selective visual attention to specific local aspects of the image, or features of the mannequin. To test the system, we conducted a within-subject study with 12 users who were tasked with drawing the still-life mannequin 4 times, once with each cue and once without projection as a control. A Latin square was used to mitigate ordering effects. We report the cognitive load of using our system in drawing, a drawing analysis by experts to assess effects on performance, and a thematic analysis of the user's experiences. We found that projected light cues are highly effective in directing attention, but they're ineffective at disrupting established drawing workflows. We also found that novice drawers tend to have an aversion to making errors, which appears to limit their exploratory behaviors, which are necessary for growth. This suggests that designers of cognition-assisting creativity support tools like these need to encourage exploration and even errors as a part of the learning process in the future. The grid cog cue provided greater self-efficacy, but it was cognitively taxing, and it complicated the ability to remain in P-mode perception because the grid was a familiar percept. The spotlights had a similar effect, which suggests a need for cues that implement unfamiliar stimuli, like novel shapes, or introduce material influences. Our user study revealed how cog cues can support those learning to draw by shifting visual perception, but that is not the only sensory modality we have. Cog cues can be extended to other senses, with potential implications for shifting or hacking, haptic, gustatory, olfactory, and sonic perception. Our work opens up new avenues for research on how creative technologies can be used to increase awareness of other perceptual effects and self-efficacy with perceptual abilities. At this time, I'd like to thank Professor Yana Payusova from the Art and Art History Department at UTA for her valuable insights on drawing behaviors. I'd also like to thank the National Science Foundation and our research participants, without whom this project would not have been possible. Thank you.